Hello everyone, welcome to Vyas Edification Quota. In this session, we are going to discuss class 12th chapter number 5 Magnetism and Matter and NCERT all and exercise solutions. Clear? So, in this session you will find the detailed solution of each and every question, as well as you will find here the detail or we can say theory behind that question also. Clear? So, definitely this session will be very fruitful to you. So, now we are going to start all the questions. So, let's start. Now dear student, we are going to discuss question number 5.1, and in this question it is given to you, answer the following questions regarding earth magnetism. Clear? So, in this question different sub questions are given to you. So, in the first slide you can see here we have total 3 questions. Clear? So, now if we talk about part number A, so in part number A it is given to you, a vector needs 3 quantities for its specification. Clear to you? Name the 3 independent quantities conventionally used to specify earth magnetic field. Clear? So, now concentrate on a screen. Now listen carefully. Let's suppose if we want to define earth magnetic field, actually we need 3 essential elements for earth magnetism. Clear? And what are 3 different essential elements we have? Number 1. So, if we are talking about part number A, definitely we can say first vector or first element that we required, this is magnetic declination. Magnetic declination. Magnetic declination. Clear? So, now what is the meaning of magnetic declination? Magnetic declination is an angle, it is made of between geographical meridian and magnetic meridian. Clear? So, now we can say, let's suppose you can assume like this, let's suppose this is earth. Clear? We can say this is geographical north and we can say this is geographical south. Clear? Now we can say this magnetic meridian is lie approximately having some angle 14.2 degree. Clear? So, we can say this is here we are having magnetic south and we can say this is magnetic north. Clear to you? So, now we can say if we talking about a plane that passes through geographical north and geographical south, and there is one plane that is passes through magnetic south and magnetic north. So, we can say the angle between these two planes, it is known as magnetic declination. Clear? So, one of the element that is used here, this is magnetic declination. Clear to everyone? Now we are going to discuss second element, and that is what? That is known as angle of dip. Angle of dip. Clear? Angle of dip, let's suppose if I am represented by del. So, what is the meaning of angle of dip? Actually, this is angle made by resultant magnetic field with horizontal component of magnetic field. Clear? So, this is angle of dip, and definitely we need one more important parameter, that is horizontal component of velocity, horizontal component of earth magnetic field. Horizontal component of earth magnetic field, and we can say that is represented by BH. Clear? So, if we talk about part number A, we need here 3 independent quantity that is used to specify earth magnetic field. Number 1, magnetic declination, second one angle of dip, and third one horizontal component. Clear? Horizontal component of magnetic field. Clear to you? So, this is all about part number A. Clear? Now we are going to discuss part number B. Clear? In part number B, it is given to you the angle of dip at a location in southern India is about 18 degree. Okay. Would you expect a greater or smaller dip angle in Britain? Now, actually all are some theoretical questions. Actually there is so many theories that is developed for the earth magnetism. Clear? Some is accepted, and this is again a fact base. It is given here. Let's suppose if you are talking about angle of dip at a location in southern India. In southern India we have 18 degree. But if we are talking about Britain, clear? Britain. So, we can say in if we are talking about Britain, Britain is situated near about north, we can say Britain is situated near about magnetic north. Yes or no? And if we are talking about magnetic north, definitely we can say angle of dip will be more as compared to India. Clear? So, it is generally seen that if we are talking about Britain, for Britain we have angle of dip, this is near about 70 degree. Clear? Now you can say, sir, how do you know? Actually, let's suppose we have a dip needle and now we are moving at a different location, at a different location of a world. Clear? So we are actually observing different dip angle. Clear? So that's why we are saying, if we go for the Britain, at the Britain we are getting angle of dip, this is equal to 70 degree. Clear to everyone? So this is all about part number B. Now if I talk about part number C, in part number C it is given to you, if you made a map of magnetic field lines at Melbourne in Australia, would the line seem to go into the ground or come out of a ground? Clear? So now if you know the geometrical location of Australia, Australia is actually located in southern hemisphere. Clear? So it means we are talking about geometrical south. Clear? We can say we have two, that is geometrical north and geometrical south. So Australia is located in geometrical south. Clear? But if I am talking about magnet, so magnetic north is situated in we can say in near about Melbourne. Clear? So whenever we have magnetic north, and let's suppose we are talking about at a surface, definitely we know from a north pole magnetic field lines will come out. Yes or no? So if we are talking about this part number C, magnetic field lines in Melbourne, definitely it will seems to go, it seems to come out of the ground. Clear to everyone? Answer is very clear. Answer is very clear. What is this? If we are talking about Australia, Australia is situated in southern hemisphere. Southern hemisphere. Clear? If you are talking about southern hemisphere, there is magnetic north will lie. Clear? Whenever we have magnetic north, definitely field lines will come out from ground. So directly we can see here, magnetic field lines come out from ground. Clear to you? Yes or no? Clear. So this is all about part number C. Clear? Now if I talk about part number D of this question, in this question it is given to you, in which direction would a compass free to move in the vertical plane point 2 if located right on the geometrical north or south pole? Clear? So now listen carefully. If I am talking about Earth, definitely we can say here we have two situations, and this is known as equator. Clear? And we can say this is known as pole. Definitely you know we have two types of pole, north pole and the south pole. If I am talking about angle of dip, clear? So you can say at equator you will find the magnetic needle that is parallel to horizontal component of earth magnetism. Clear? It means here we will find angle of dip 0, but as we move from equator to pole, at pole we will find angle of dip that is equal to 90 degree. Clear? So you can say, if you are either you are talking about north pole or south pole, angle of dip is 90. Whenever we have angle of dip 90, it means we have only vertical component of magnetic field. Clear? There is no horizontal component. So it means we can say, if we are now talking about geometrical north or south pole, clear, we can locate that needle in any direction, because there is no any external, there is no net magnetic field is acting in horizontal direction. Clear? So this is all about part number D. Clear? Done. Now if I am talking about part number E, in part number E it is given to you the earth field, it is claimed roughly approximately the field due to a dipole of magnetic moment 8 into 10 to the power 22 joule per Tesla, okay, located at its center. Means we can see here one value is given to you, this is magnetic moment value. Clear? Magnetic moment we have 8 into 10 to the power 22, this is joule per Tesla. Clear? It is also given it is located at its center. Fine. Check the order of magnitude of this number in some way. Clear? So let's suppose if we calculate here magnetic field at equatorial position, you can calculate in axial position or equatorial. Let's suppose I am calculating with equatorial position. Clear? So if we are talking about equatorial position, we know formula is given by mu naught upon 4 pi, this is multiply m upon r cube. Clear? Mu naught upon 4 pi. Mu naught upon 4 pi equal to what? 10 to the power minus 7. Clear? And it is multiplied with small m. Now what is small m? Small m is known as magnetic dipole moment. So we can see this is 8 into 10 to the power 22 divided by, now what is value of r? Now here we will take value of r, that is radius of earth. Clear? And we know this is equal to 6.4 into 10 to the power 3. Clear? 6400 kilometer. So we can say 6.4 into 10 to the power 3 into, we can say 10 to the power 3 whole square. Clear? Yes or no? We know radius 6400 kilometer, we can convert into meter, so we can write like this. Clear? Here we have cube. Clear? Now if we simplify, we can write like this, 8 multiply, we can say this is 10 to the power 15. Clear? And divided by, this is what? 6.4, 6.4, 6.4. 6.4 multiply 6.4 multiply 6.4 multiply. I can say this is 10 to the power 6. So we can write like this, this is 10 to the power 18. Clear to you? So from here you can say this is equal to what? 10 to the power 3. Clear? 8 upon 6.4, 6.4, 6.4. Clear? So you can say this is approximately 216. Clear? 216, it means you can say approximately you will get here value, this is 0.3 something. Clear? Or you can also write like this, if you calculate you will find here this value 3 into 10 to the power minus 4. Clear? And we can say Tesla. Clear? You can also write like this, this is equal to near about 0.3 Gauss. Clear? Yes or no? 0.3 Gauss. Now, so from here you can see, we are getting this value, and this is near about the earth magnetism value. Clear? So now we can say that this value that we are assuming, that is perfectly correct. Clear to you? Now if we are talking about part number F, in part number F it is given to you in a question, geologists claim that beside the main magnetic north-south poles, there are several local poles on earth surface oriented in different direction. How is such a thing is possible at all? Clear? Actually, you know, in our earth we are assuming we have two poles only, north and the south poles. Clear? And we are also talking about equatorial position, but you know that it is assumed that we have so many position of a pole. Clear? So why this is happening? Actually we can say in our earth we have so many magnetic materials, and these magnetic materials are located at different location. Clear? So definitely they are responsible for we can say for small north and the south poles. Clear? So definitely we can say here, yes, definitely we have main north and south poles, but apart from that poles we have so many small north south poles also. Clear? So this is claimed by geologists. Clear to you? So this is all about this question. Clear?